Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is on MCQ in front of you about Furan derivative. Okay, so I request you student, please pause the video, read the question carefully and try by yourself. And whatever answer you get, please write in the comment box along with few words as explanation. Remember one statement that self-evaluation is essential for improvement, and that's why you should try. And don't worry, after some time we'll get the right answer with proper explanation. I believe you have tried by yourself, it's my turn to give you the right answer. So let's understand the question little carefully. This is actually a reduced form of furan derivative. It's because tetrahydrofuran is this one derivative. So no, fine. So it is reacted with alumina Al2O3 400 degrees centigrade, very high temperature. And we know that in case of Al2O3, this aluminium is in +3 oxidation state and it is actually significantly strong acidic. Now there are two options possible, that this alumina can bind with this OH or it can with this lone pair of this oxygen. Actually student, the answer of this question is option C. Now how this produced? Based on my understanding, I believe the mechanism is this is completely my understanding based result. So first this lone pair of oxygen will coordinate to this alumina through Lewis acid base interaction. Fine. After this donation, actually alumina will have a formal negative charge on it and oxygen will have a formal positive charge. You can consider like that. Now what in the next step, what you can expect, that these bond will break. Why from this side? Because from this side it will produce a secondary carbocation. So this is actually a secondary carbocation. If you consider this other side here, then it will be a primary carbocation, and we know secondary carbocation is relatively more stable due to compared to the primary one because of point number one hyperconjugation and point number two is plus I effect. Now in the next step what you can do, see this cationic charge is neighboring to this OH. So what you can expect, that these OH can do a neighboring group participation type reaction to stabilize this carbocation. How? It can attack this carbocation center. Fine. And it can produce an epoxide. And by the way, not only epoxide, you may consider it's a protonated epoxide type. Now just look at this molecule little carefully. So this one side is protonated epoxide and another side is alkoxide derivative. So these alkoxide can act as nucleophile, and protonated epoxide is actually student a good electrophile. Now this both center, so this is actually the this carbon center and this carbon center both are electrophilic because it's attached to electronegative atom oxygen, and not only oxygen, this oxygen is carrying a positive charge, so more electronegative, or more electron deficient. Now this alkoxide, which position number 1 or position number 2? Obviously position number 1, because this attack is like a nucleophilic attack on this epoxide, so it will happen from the less bulkier side, and in this way this epoxide ring will be open. By the way, I have already discussed a dedicated lecture on epoxide opening under acidic, basic or Lewis acid mediated pathway. So please visit for better understanding. I shall provide the link in the description box. So in this way the reaction will happen. Now in this case I request you student, please count how many number of rings are produced. So this is 1, 2, 3, 4, 5, 6. So this ring will be 6-member ring. Fine. And this number 1 is oxygen. So this is oxygen. So still there is an aluminium. I am not removing. So this is 1, 2, 3, 4. Obviously in 5 it will be OH attached, and this is 6. Now still reaction condition, in the reaction medium there is alumina, which is a stronger Lewis acid and heterogeneous catalyst, and by the way I have already discussed a dedicated lecture on this heterogeneous catalyst. Please visit, it's a very interesting thing for industrial chemistry. Now so this alumina is present and temperature is 400 degree, very much drastic condition. So what is expected, that there is one proton, and this proton could be abstracted. So in this way it will come and it will open, and ultimately it will produce this alkene. And by the way, you may think that sir, hydrogen is also there for this number 4 also. Why not this? Because in this alkene the product dihydropyran is relatively more stable. Why? Because of resonance. How? there is a lone pair of oxygen, lone pairs, two lone pairs, so it can come, it can open. So in this way what it can produce, so this is negative charge, this is double bond, this is oxygen carrying a positive charge. So you can consider this part, student, see, enol ether derivative. And by the way, one of the best example in this context is silyl enol ether or enolates, and they are nucleophilic. So this center actually can act as nucleophilic, and based on this concept, these DHP or dihydropyran is utilized as protecting, means utilized for the protection of alcohol. Okay, so that's another chemistry, we'll discuss in some other videos. I've already discussed this thing previously. Now, so we have understood these alkene is actually resonance stabilized or delocalized, so that's why it will be produced in this reaction. Now, so what is the answer? Just some time before I told that this option C is the right answer. Now question, if it is given in your exam, how can you come to the answer less than 30 seconds? First of all, you need to understand that these oxygen you can consider more electron rich because it's attached to carbon. Not only that, it's a secondary one, and if it comes out, it will produce a secondary carbocation. Whereas if this OH leaves, what it will produce? It will produce a primary carbocation. So primary carbocations are relatively less stable. So reaction will start from this. So this is the Al3 plus, and now first of all it will produce a carbocation, and second again ring closure happen. And by the way, if you look at little carefully about the reaction, furan formation not possible because that much dehydration is not happening here. Only one molecule of dehydration possible. So one from a cyclic compound, one molecule of dehydration will get a single double bond. So which compound have single double bond? B and C. So option D is also gone. So if you compare B versus C, in this case what can eliminate? OH. Water can eliminate. So how carbon number reduction possible? Obviously not possible. So this is no. So if you don't understand the basic chemistry, also you can come to the right answer. How? First you need to understand that this is high temperature, Lewis acid is there, dehydration possible. And dehydration, 1 unit of water will be produced from one molecule. So two double bond formation not possible in the ring. So option A gone, option D gone. Now option C and D comparison. Option, in case of C there is in case of option B there is less number of carbon, but in this case only water is eliminating. So how carbon number could be reduced? Not possible. So this is gone, option B. So ultimately what is left? This option C. So this is the right answer. Okay, so in conclusion, what you have learned today, that Al2O3 is a very strong, porous, heterogeneous and cheaper Lewis acid because of the presence of this aluminium 3 plus ion. Now this alumina is stable at higher temperature because of its very strong aluminium oxygen bond, which also has this d-pi p-pi back bonding, means the lone pair of oxygen could be donated to the energetically accessible vacant d orbital of aluminium atom. Now oxygen can form strong Lewis acid base adduct with aluminium center because aluminium center is Lewis acid and oxygen is hard donor. And this aluminium 3 plus center in Al2O3 is actually a 6 electron species, student. That's an interesting property. The 3-member ring formation, means this epoxide produced, is associated with proper conformational orientation, but this is strained because ring numberless 3-member ring. It's near about 60 degree. So between 5-member and 6-member ring, the 6-member ring is relatively more stable due to relatively lesser ring strain. Why? Because if you look at the bond angle for cyclopentane ring system, it's closely to 107 degree. But if you consider the cyclohexane system, its ring system, the angle is closely 109.5 degree. Means this is the actually tetrahedral angle. So ring strain is less for cyclohexane derivative. So that's why it is relatively more stable. Okay. So this is the end of discussion. I believe this video may be useful. Please write your opinion in the comment box and please help this channel to grow if you consider the content are worthy. And if possible, please visit my another channel, Climate and Chemistry, where I upload global warming and climate change related videos. So thanks for watching. See you in my next video. Bye bye.